This video, I am discussing 7th Standard Mathematics, Chapter-1, Integers, multiplication here, multiplication and the multiplication properties of integers. We will saw properties of commutative property for multiplication, associative property, distributive property, identity property, inverse property, and many more in this video. See, this is commutative property. This is associative property. This is for distributive property. See examples and many more. Multiplication of integers. Multiplication of a positive and a negative integer. What happens if we multiply a positive integer and a negative integer? See, we know that multiplication of whole number is a repeated addition. Multiplication of whole number is a repeated addition. This is a fourth class concept. Multiplication of whole number or any number. Multiplication of any number is a repeated addition. Example, 5 plus 5 plus 5. Here 5 appears in 5 times. 5 appears in 3 times. Therefore, 3 into 5 is equal to 15. We know that this is a number line. This is a number line 0, 5, 10, 15. 5, 10, 15. This is positive x-axis. This is negative x-axis. This is negative x-axis. This is positive x-axis. Here 5. This is number line. Next 5. Next 5. Total 1 time, 2 time, 3 time. 3 times 5, it gives 15. Similarly, can you represent addition of integers in the same way? Integers means z or I. We represent integers as z or I. This is capital Z, set of all, -3, -2, -1, 0, 1, 2, 3, and so on. This is integer set. Yes, we can represent integers in the same way as we represent integers as a whole numbers. Addition of whole numbers in the same way as addition of integers. See, we have from the following number line. Number line is, this is the number line for negative integers, 5, 10, 15. This is negative side. If we move from left side, negative numbers appears. I already told this side. Move 0 to 5, -5 to -10, -10 to -15. This is -5 plus -5 plus -5. It gives -15. That means 5 minus 5 plus minus 5 plus minus 5 3 times minus 5, it gives minus 15. See, while multiplying a positive integer and a negative integer, we multiply them as whole numbers and put a minus sign before the product. Thus, we get a negative integer. We get negative integer. Example, minus 2 into 9. Minus 2 into 9, it gives 2 into minus 9. Or else, take it minus sign outside and multiply these two numbers, put negative sign. And also, minus 33 into 5 is equal to 33 into minus 5. It gives, put minus sign, product of 33 into 5 is 165. That means minus 165. In general, for any two positive integers, A and B, we can say A into minus B is equal to minus A into B is equal to minus of A into B. Next, we multiply the two negative integers as a whole numbers and put the positive sign before the product. If we multiply two negative integers, see, A and B are two negative integers, multiply minus into minus. We know that minus into minus is plus, plus this, and for example, minus 10 into minus 12 is plus 120. Similarly, minus 15 into minus 6, it gives plus 90. In general, for any two positive integers A and B, minus A into minus B is equal to A plus B. Properties of multiplication of integers. Closure under multiplication. This is closure property. The product of two integers is again an integer. The product of two integers is again an integer. So we can say that integers are closed under multiplication. Integers are closed under multiplication. In general, A into B is an integer. A into B is an integer for all integers A and B. Example, minus 20 into minus 5 is equal to 100. Product is an integer. Second one, property of multiplication. Commutativity of multiplication. See, in general, for any two integers A and B, A multiplication B is equal to B multiplication A, or else A into B is equal to B into A. Multiplication is commutative for integers. This shows multiplication is commutative for integers. Example, minus 3. Example, 3 into minus 4 is equal to minus 12. And minus 4 into 3 is equal to minus 12. Here, A into B is equal to B into A. That means product is same for A into B and B into A. Therefore, commutative property holds in integers. Next, multiplication by 0. In general, for any integer a into b, a into b here is 0, a into b is equal to b into a is equal to 0. That means if we multiply any number with 0, we get 0 as the answer. For example, minus 3 into 0 is equal to 0. See, multiplicative identity. Multiplicative identity. One is the multiplicative identity for integers. One is the multiplicative identity for integers. See, one is the multiplicative identity for integers. In general, for any integer, a, we have a into 1 is equal to 1 into a is equal to a. Example, minus 3 into 1 is equal to minus 3. That means if we multiply any element with 1, we get that element only. This is the property of multiplicative identity. Next, associativity for multiplication. In general, for any three integers a, b, and c, a into b into c is equal to a into b into c. Consider minus 3, minus 2, and 5. See, verify associative property for multiplication. Multiplication of integers. See, a into b into c. I am checking this property. Here, a here minus 3 into this is b minus 2 into 5. Minus 3, put minus 3 as it is, into minus 2 into 5 is minus 10 is equal to, this is minus 30. Minus 30. And next, a into b into c. I'm checking this. First one this. And next this. Minus 3 into minus 2 into 5. This is minus into minus. This is plus. Here minus 3 into minus 2 is 6 into 5. This is 30. Therefore, a into b into c is equal to a into b into c. From 1 and 2, association for multiplication is same. This shows associative property for multiplication holds good. Next, distributive property. In general, for any integers a, b, and c, a into b plus c is equal to a into b plus a into c. the distributivity of multiplication over addition is true for integers. Example, 16 into 10 plus 2. This means 16 into 10 plus 16 into 2. 16 into 2. 16 into 10 means 160. 16 into 2 is 32. 160 plus 32 is 192. I will discuss exercise 1.2 in next video. Thank you for watching.